G'day viewers. In this segment we'll talk about virtual private networks. So virtual private networks are a very useful networking construct that allow us to run our own private network on top of the internet. To do that, messages need to be secured as they're sent across the internet, and this is usually done with a scheme called IPsec for IP security. We'll look at both of these topics in this lecture. Let's start with a little bit of motivation. I've told you before, the best part of IP connectivity is the fact that you can simply send a message to any other host on the internet. It's wonderful. The worst part is, well, the same thing. Any other host on the internet can send packets to you. And there's a lot of nasty stuff out there. You may not want packets from any other host, particularly if you're trying to implement your own private network. So it's often desirable if you have a company here we have 3 different sites, A, B, and C. It's often desirable to implement your own network that is somewhat separate from the internet. It will connect all of the different sites of your company, but not allow any random person on the internet to inject packets into your own corporate network. If you wanted to do this, you could actually do this by building your own physical network. What you would do is you would actually you would rent or lease a line. This is a leased line. Just think of this as a private link. If you call up a telecommunications company, you could get one. And it would cost you money. But it would be a link for your own use, which is physically separate from the rest of the internet in some way, so that internet packets, regular internet packets, don't travel over it. We'd still need some way to connect this corporate network to the internet, assuming we wanted to allow people on the corporate network to ever get to the internet. But this would be through control points of interconnection that I haven't shown here. So the network I've shown here is separate from the network, and so you can see Eve here, well, or Trudy, who exists on the physical, on the public internet, then has no real way into the private network. They're separate. However, let's advance our thinking a little bit. Here's a brilliant idea. You know, those lease lines were kind of expensive, so the brilliant idea is, let's just use the public internet instead of lease lines. That will be much cheaper. It might also be more reliable as a better managed service provided by ISPs and so forth. In this case, what we're going to try and do is run a logically separate private network on top of the internet. So the separation will be logical, not physical, in the sense of having different links through which private and public internet traffic go. You can see that this could afford you many cost savings, for instance, but it raises a lot of security problems since we now have a logical separation. In fact, this kind of network is called a VPN, a virtual private network. And now, since we're all using the internet, Trudy here maybe has a chance of messing up your security. So the goal and threat model for a VPN, let me just go over it briefly, so again we know what it is we're trying to accomplish. The goal here is to maintain our own logical network, called a VPN, a virtual private network, that runs on top of the internet, yet is separated from it, so that traffic can't go from the public internet onto the VPN, or vice versa. If you're on the VPN, you can't get to the public network, except via specially designated gateways that might scrub traffic for that purpose. The threat here is that Trudy, who is also on the public internet, will somehow be able to send packets from the public internet to your VPN, or vice versa. She'll be able to get packets out of your VPN and understand what they're saying, read the contents of messages and so forth. Now, in the ideal case, we'll perform this separation so that Trudy's on one side and our VPN is on the other side, as though it was composed of physical leased lines. That's what we want to get. So I'm going to go over a couple of things to explain VPNs to you. First of all, I'm going to talk about the mechanism. How is it that we can create these virtual links and send packets over them? And then I'll talk briefly about how we would secure messages over these links, because that turns out to be the standard solutions almost. Okay, so the question here for us is, how can we build this virtual link, a virtual link or a tunnel? Now in the figure here, I have a corporate network on 2 sides. You can see I have here private network A and private network B. Just think of that as 2 different sites from one company. So hosts in that network, such as this host here, would like to be able to send packets to other hosts. Maybe there's some other computer just here in the network, or they would like to be able to send packets all the way through to some other host who's also in the corporate network. It just so happens to connect these two remote sites, we're using the public internet with this virtual link or tunnel. So for hosts inside the private network, we want them to work normally. They just send packets with addressing according to whoever is in this private network. To cross this virtual link or tunnel, this is where we have to do something special. And all we need to do actually is encapsulate packets as they go out of this tunnel endpoint and change the source and destination address so that they will go into this tunnel endpoint. So if you send a packet out of this router, the only place you want it to go is into this router, this other tunnel endpoint, so that it can reach hosts on the other network. This is a tunnel. Just to be a little clearer maybe about how a tunnel actually works, what we should do is we should look at our usual kinds of protocol diagrams, because they'll explain to us what's going on at these different points. When I said a tunnel endpoint encapsulated the IP packets as they went out so that they would reach the other tunnel. This is what's going on if we look at this protocol diagram. Actually, encapsulation is often called IP in IP. The simplest way to encapsulate is to sort of add another IP header. Okay, but I'm jumping ahead. Let's look at this diagram carefully. So on the very left, we have just a host on the private network, and maybe they're sending to another host on the private network on the very right-hand side. The routing is going to take us through this tunnel endpoint here on the left, and then we want to go all the way to the tunnel endpoint on the right across the public internet. You'll see the difference is, so actually we're going to have an IP layer all the way across here. This is the top IP layer. It's all the way across all of the devices which you use to handle packets in this private network. But there's something funky going on at the tunnel endpoint here. We have this. There's an extra IP layer. We have an IP layer. That's the one that we're using at the host to communicate. And underneath it, we have this other IP layer here. So that means that IP is running on top of IP. In fact, and it's talking to a corresponding endpoint on the other end of the tunnel. Here's the other layer. So what we're really doing is using, normally we would have a link would be something like an Ethernet where we would go one hop. Here with IP underneath, we are using IP, the public internet, as one hop. In fact, as you send from one particular tunnel endpoint to another tunnel endpoint using IP, you may cross over many different routers that are in the public internet. That doesn't matter for us. The packets that are going between the tunnel endpoints won't see all of these other routers. It will be as though they weren't there and it was just one big virtual link. So this is how a tunnel works. And this extra IP layer, which is sandwiched in here, is going to add an outer IP header. Or it's going to modify somehow the existing IP headers to provide for delivery from one side of the tunnel to the other side of the tunnel without allowing any escape from the tunnel while you're on the public internet. Let's look at that just a little more by looking at what a packet looks like as it goes across the tunnel. So here on the inside, you can see I've got the inner packet. That's shown in pink here. And I showed encapsulation not simply as adding a header, but wrapping, because often the contents here is going to be encrypted in a tunnel. So you wouldn't be able to see them literally because they'll be encrypted. Now, this inner packet, it has an IP header, and it will have source and destination addresses, IP addresses, which will correspond to the hosts in the private network. Because this is just another packet going across the private network. As far as those hosts are concerned, they might not even realize that the public internet has been used as a link between some portions of their own private network. What the tunnel endpoint does is it adds this outer layer of IP addressing. This is the tunnel, the header that's put on by the tunnel. This extra IP header here will have a source address, which is the tunnel endpoint which made it, and a destination address, which is the remote tunnel endpoint to which this whole unit is destined. And that way, this inner packet will be carried across the public internet. So now you've seen tunneling with about 3 different pictures showing different aspects of it. And hopefully the concept makes sense to you and you understand how a tunnel works. Well, to get to a VPN is essentially a set of tunnels, but in addition to that, we need security. So tunneling alone is not secure. We've worked out how to build this logical structure on top of the internet and tie together the little islands of a company that all were connected to the internet. By the way, I should say one island could be a single computer, which is you on a work trip, or a single computer, which is you at home connecting in to the corporate network. But this tunneling, as we've seen it so far, is not secure. We don't have any of the usual properties we care about: confidentiality, integrity, and authenticity. If we simply slap an outer header on them, then Eve on the network can look at the contents of the packets which have been sent across our VPN. That's not good. Trudy could also send packets to the remote tunnel endpoint, and she could maybe fake packets so that they'll be accepted and get into the private network on the other side. That's not good. Both of these things violate the kind of separation that we wanted. And so the solution we need for security here is fairly straightforward. We need all of our usual cryptographic protections to make sure that messages which are sent from one tunnel endpoint to another tunnel endpoint have all of the usual confidentiality, so Eve can't read them, and integrity and authenticity, so Trudy can't tamper with them or inject her own messages. Well, to do that, we'll simply use cryptographic protocols of the kind we've looked at. We've looked at how these kinds of properties are provided, both at the link layer with 802.11 and at the transport layer with SSL for the web. Well, here for VPNs, we're going to use a different scheme, but conceptually it's doing a lot of the same things. The scheme we'll use is called IPsec, short for IP security. This is often used for VPNs. It provides security at the IP layer, so it's going to wrap up these IP packets in a nice secure way so that we can send them across the tunnel endpoint. For VPNs, the level which we want to secure is the network layer, which is why we're going to use IPsec. Okay, so I have just one slide for you on how IPsec works. There are actually lots of interesting details in IPsec, but given the lack of time, I'm not going to go into them. You can read a little bit more about them in your text. I will say, like many other things, so IPsec is a long-standing effort to secure the IP layer by adding security. In the same way that we've been trying to add various kinds of security and even IPv6, many of these efforts on DNS security have been around for a long time. It's just adoption has been fairly slow until recently due to various problems. But what IPsec will do, and it's all standardized, is add confidentiality, integrity, and authenticity to the network layer, to packets as they're sent across the internet. Actually, there are many options and you can have various combinations of all of these things. So I'm just showing you one particular mode, tunnel mode, which is going to add all of these properties. So briefly, here's how IPsec operates. Like all cryptographic protocols, we need keys. So keys need to be set up for all communicating host pairs. These host pairs, this is the tunnel endpoints. And you might note, because I said the pairs, what we're really going to do here is end up setting up a pair, a key amongst a pair of hosts that we're going to use for a symmetric encryption scheme. So that will be fast. That will provide a fairly efficient way to encrypt information as it goes across the internet. So these keys need to be set up. This is one reason why IPsec is often used with VPNs, because we'll be configuring the tunnel endpoints anyhow. You have to know how you're talking to. So we can often easily add keying information to them. Whereas it's more difficult to simply talk to random hosts on the internet with IPsec because we haven't established keying. So once we do that, actually interestingly, communication across using IPsec from one IP host to another IP host tends to look a little more connection oriented than does pure IP. That's because we have to make sure that we've got all of the session keys set up and other parameters and so forth. So it's almost like a connection is established before we can just begin sending. Again, this fits very well with a VPN where the connection is setting up a tunnel and then using it to send many packets. And as we go over the tunnel, we talked about encapsulating the packet. So the IPsec layer will add information to secure the packet. Actually, you can see here in the picture, it adds both a header and a trailer. Now in this picture we have, here is the old packet, the old IP header. This was the one on the private network that's going between two hosts on the private network. Here's the new IP header that we slapped on as we went over the tunnel. And with just these two things, we don't have our packet secured to provide confidentiality, integrity, and authenticity. So what IPsec does is it adds these two other blocks. This is when you're using it in a particular mode called tunnel mode. It adds a header. This is called, I think, the ESP header, Encapsulating Security Protocol, I think. And this header provides information about encryption, and you can see here the whole body of this packet. I'm going to hash it out because it's all encrypted, you can see here. IPsec also adds a trailer. That's this thing here. This is an authentication token. It's actually a MAC. HMAC is the particular algorithm that's often used, but it's a MAC as in a message authentication code of the kind we looked at when we talked about crypto designs. And this authentication tag is authenticating everything here. I'll hash in the opposite way. So it's authenticating everything, even including the ESP header. And when we've done that, we've got all of our properties, and that is IPsec in a nutshell. Okay, so I'd like you to take away a couple of things from this lecture. First of all, just the idea of VPNs, how we can build these logically separate networks on top of the internet. This is a very useful building block for networking in general. And like some of the other devices we've seen, like firewalls and so forth, it really alters IP connectivity, the IP connectivity that hosts see. In this way, it alters the IP connectivity maybe in a beneficial way to build these separate networks. Now, of course, to do this, to really accomplish the goal of separating things, VPNs need some kind of cryptographic protections to secure the messages. And traditionally, IPsec is used with VPNs. It's a fairly standard design in some ways. We've looked at all of these different properties and ways they can be provided by cryptography. IPsec does this at the network layer, and that's VPNs.